Welcome back to Open AI Build Hours. I'm Christine. I'm on the startup marketing team, and today I'm joined with Katia.
Hi, everyone. I'm Katia, and I'm on the Developer Experience team.
So Katia is actually back for her second Build Hour, and she's going to be in San Francisco all summer. So we're really excited to have her. We have a really fun topic today. It's all about built-in tools. But before we start, I did want to revisit the goal of Build Hours for anyone new joining us. The goal of Build Hours is to empower you with the best practices, tools, and AI expertise to scale your company using OpenAI APIs and models. So as you're familiar, here is our homepage where you can register for all future Build Hours. We have some exciting topics coming up, especially in August. So stay tuned and be sure to check it out. So here's a snapshot of what you can expect today. First, we're actually going to explain what are built-in tools, go over some concepts and all the available tools that you can use as of today. Really excited for this next one is we're going to show you the playground. Katia is going to do a run through of how to experiment and iterate quickly using the tools in the playground. And then we're going to bring built-in tools into your app. We're going to be building a data exploration dashboard today. And then we will save some time for our customer spotlight. We're going to be joined by the technical lead at Hebbia to go over how they used web search for finance and legal workflows. And then we always have time for Q&A. Our team is in the room with us to answer questions live. And then Katia will actually take over and answer a few of them towards the end. So with that, Katia, feel free to jump right in.
Great. Thank you, Christine. So hi, everyone, again. Really excited to talk about built-in tools today. But first things first, let's discuss about what it is. So there are actually two parts in that name, built-in and tools. And so the tools part refers to the ability to add capabilities to the models, because LLMs, they're great, they can do a lot of things, but when you want to build apps that can interact with your own data, when you want to build agents that can take actions for you, LLMs can't do that on their own. So they need tools to be able to perform those actions. And so that's what we're going to talk about today. And the out-of-the-box part, so the built-in part, it means that you don't have to code anything, you don't have to do anything on your side, you can just use it. So you can pick from a range of hosted tools. We'll see which ones in a second. And then you can just add that to your app, add that to your agent, give the models access to them, and just very easily you can add these capabilities to your models to, for example, search data, either like live data or data in your systems. You can perform complex tasks. And again, since it's out of the box, it means you don't have to code anything, and you can just leverage them whenever you need. Okay, so what's the difference with function calling? Because some of you might be familiar with the concept of function calling. We actually did a build hour for function calling a few months ago. So if you don't know what it is, really quickly, it's the ability to tell the model, okay, you can use these functions that you define in your code, and the way it works is that you tell the model that how it should use this function. So it will just give you parameters that you can then use to call the functions on your side, and then you tell the model what the response is, what the result is. So if you want to do function calling, there's actually 3 steps that are important. So we have a little diagram here. We're going to focus on the 3 steps in the middle. So once the model decides, first you need to tell the model, okay, these are the functions that are available to you. For example, you can have like a get weather function, and this is how you should call them. These are the parameters that you need. Once the model actually decides to call the function, it will tell you, okay, I think you should call this function now with these parameters. So that's the first step. And then the second step is that you actually need to take that and then execute the function on your side. So for example, you have some code defined, or you need to call an API. So you just take those parameters, execute the function, then you get a result. And so the third step is to tell the model, here's the results. You add it to the conversation history, to the conversation context, so that the model knows what the result is, and it can then finally generate a final response. So that's function calling. If we look at built-in tools now, it works differently, except for one tool computers use. We'll cover it in a second, but it works differently because you don't have to execute the code on your side. It's directly executed on our infrastructure. So you can just tell the model, I want you to use these tools when you need. And then when the model thinks it's right, it will call these tools. But instead of telling you, okay, you need to call this tool now, it will actually execute it automatically and add the results to the conversation history, to the context, and automatically generate a response as well. So on your side, you don't need to do this step in the middle. You just need to let the model know you can use this. And then once it decides you can use a tool, you will directly go to this final response here. And so it's all transparent to you. So that's like the beauty of built-in tools. You don't have to handle them, and also you can, in addition to benefits, in addition to like using our expertise, because we'll cover which tools you have access to, but you don't have to think about how they are built, what's behind them. You can also use our infra. You don't have to execute anything on your own infrastructure. Okay, so which tools are available now? We have 6 tools that are available as of today. Just to give you a little background, we first introduced the first tools were introduced at the same time as the responses API. So it launched earlier this year around March. And after that, a couple of months later, we added a few more tools. And so the one that I think everyone's the most excited about is web search, because as you know, LLMs have a cutoff date, so they're not aware of what's going on right now in the world. Like the training data stops at a certain point. So for our current models, their cutoff date is May 2024. So that means everything that happened after, they're not aware of. So you can't ask them what happened like last month, because they have no idea. It's not in their training data. And so if you want the models to know what's happening right now, you need to give them access to the internet. You need to give them the ability to search the web or connect them to a news source. And that's like pretty cumbersome to build. And so with web search, we are actually giving you the capability we're giving the models the capability to search the web without any effort. So we're using our own services, our own index, so that the models can know what's happening in real time, and you don't have to build anything again. So the second tool that is very exciting as well is file search. So file search is giving the models the ability to search your knowledge base, your own database of files. So some of you might be familiar with the concept of RAG, retrieval augmented generation. And so that's the action of giving the models in their context some internal knowledge or some knowledge that they can use to generate the response. So if you want the models to know about something that is not in their training data, that is, for example, your own internal data, your own sources, you don't want to train the model on it. You don't want to fine tune the model on it, because it won't do anything. You want to find that information, find the right context at the right time, and just use it in the system prompt or in the user prompt. Just give it the context that it needs to generate the relevant answer. And so that's called RAG, and it's also pretty cumbersome to build. Like you need to first pre-process all of that data, then you need to retrieve it, retrieve the right information at the right time. And so all of that can be automated with the file search tool, and we'll come back to it in a second so you can get a sense of how it works. The third tool I want to talk about is the MCP tool. And that one is actually extremely exciting, because it's not just one tool, it's giving the models access to hundreds and hundreds of tools. Because with the MCP tool, you can get access to any remote MCP server. So for those who don't know, MCP means Model Context Protocol. And so it's kind of a convention that has been introduced recently, where you can just tell LLMs how to use your own functions. So let's say you have like an API and you want LLMs to interact with it, you can build an MCP server to let the LLMs know, okay, these are the functions that you have access to. These are the parameters that you can use, and just give me that, I'll give you the answer. So it's kind of the same as function calling, except it's like any person who defines their MCP server, they can give access to any LLM to their own functions. And so with MCP tool, we'll see a couple examples of MCP server. You can really give your models any tool that that you connect to it. So it's pretty powerful. The next one I want to talk about, it's pretty powerful as well, they're all great, is the code interpreter tool. So the code interpreter tool can come up with code to solve problems. So it's really powerful for things like data analysis, for example, and then it can execute the code. So we run the code again on our infrastructure and then give you an answer. And that answer can be just text, or we can even generate charts. So we'll see an example of that as well. And then the last two tools that we won't talk about today, but you can find resources about them if you're interested, are computer use, which is a little different because that tool lets the models use interfaces, computer interfaces visually, like if they were humans, so they can tell you, oh, I need to click on that button, or I need to scroll down the page, and then you still need to execute that on your own computer environment. So that one is a little there's an extra step you need to execute on your own environment, but it's still pretty straightforward. So you can find resources on that, and Christine will probably share in the chat. And so the last tool that we have is image generation, but that's like a whole other topic, so we won't cover it during that build hour. Okay, so now that we've introduced all of these tools, let's actually see it in action. So for that, I'm going to use a playground, which is our kind of experimentation lab on our platform. We haven't really talked about it during build hours before, and so that's why I wanted to talk about it now, because it's a super helpful resource, very convenient when you just want to try things out. You don't want to build a whole app or like write a script. You just want to like visually try things, and so for trying out tools, it's the perfect interface. So we'll first try out the tools in there, and then we'll move on to another demo. So in the playground, I'm just going to do this very simple prompt. Let me switch the playground here, and I'm going to add this very simple system prompt. So this is the playground. Again, if you're not familiar with it, you can find it in the platform in dashboard. It just moved. We used to have a playground top level nav item, and now it moved to dashboard. And so you can use it for chat, for audio, images, etc. But we'll use the chat one today. And here you can add any tools that you want. So for example, here I can start with the file search tool. I'm going to add it here. And so the file search tool, the way it works is it connects to a vector store where you have previously uploaded your files. So for example, here, I don't need to create the vector store myself. I can just upload the files, and the playground will create the vector store automatically for me. And that's all I have to do to kind of prepare the usage of the file search tool. So now that I did this, my files were automatically pre-processed. What that means is that they were chunked, so they were split in multiple little pieces. They were embedded, so they were converted into vectors, so they could be uploaded to the vector store. So that's something that you would normally have to do yourself, and that can be pretty daunting if you don't know what you're doing, because there's a way to optimize the chunk size. There are many things you need to think about when you build your own RAG pipeline, and here we take care of that for you. So you don't have to think about it. You just have to upload your files to the vector store. And so here I'm just attaching them. And just to give you an idea, these are the two files that I uploaded. So this is just blog posts about the tools that we shipped, and I just exported that as PDF, and that's the two files that I'm attaching here. So now I can ask any question about these files. So for example, I can say, what are the tools OpenAI, I'm going to just copy paste it here. What are the tools OpenAI shipped in the responses API? Give me a concise answer with bullet points. And so here you can see that it actually searched through my files. It's giving me annotations. So it's giving me the reference, which files did it find the information in, and it's generating this answer. So from the two blog posts, it got the 6 tools that we just discussed, because 3 of them were in the first blog post, the others were in the second blog post. And so all of that is something that the model doesn't know, because it's not public information that was shared before May 2024. So it really used our internal knowledge to be able to answer. And again, like the RAG part, it's not just the pre-processing, it's also the retrieval part. And we're also optimizing that for you. So you don't have to think about, finding the most relevant files for your user input. You don't have to think about how you would re-rank those results, like rearrange them to really use what's most helpful. You can offload that to us. So that's for the file search tool. Now I want to try the web search. So let me just remove that one here, and I'm going to add the web search tool. So the web search tool, you can configure it a little bit. I'm just going to select the country here. What that means is that the results will be using these settings. So if you set a user location, for example, and you ask for like great restaurants in the area, it will know where the user is. So it's like when you are searching the web from your laptop, Google knows where you are. Well, that's kind of the same concept here, but it's optional. So for example, I can ask anything that would be like public data on the web, public data on the internet. So for example, I can say, when is GPT-5 expected to launch? And again, this is not internal knowledge. This is going to be searching the web for an answer. And so apparently the web says that GPT-5 is set to launch in August 2025. So I don't know, we'll see. I cannot confirm nor deny that information. Okay, so now that we've seen how the model can access either your own internal knowledge base or public information on the web, we're going to see how it can access functions from other application, other providers with the MCP tool. So I'm going to first start by adding an MCP server for Shopify. So this is a list of example MCP servers. You have Zapier, Shopify, Intercom, etc. You can also create your own MCP server. So if you have an API, you can just interface it with an MCP server and host that yourself, and then you can connect through the responses API, through the MCP tool. You can connect to a custom MCP server, but these are just the examples that we have in the playground. So I'm going to use the Shopify one, and I'm going to use this store, which is an e-bike store, and I'm going to call it Cowboy e-bikes. And so when I connect to it, it's first going to fetch all of the tools that are available on that MCP server. So if we look at that, we have, these are all the tools that Shopify is exposing on all of their stores. So search shop, catalog, get cart, update cart. So I mean, any store that's on Shopify, you can interact with it through LLMs via this Shopify MCP tool. So I'm going to add it here. And then I'm going to say, so I'm, as Kristen mentioned, I'm in SF now for the summer. And so I was doing Waymo because it's SF, but it's pretty expensive. So I want to find another option to commute. So I'm going to ask the model here to help me find a suitable e-bike. So I'm just going to say, I just want something not too expensive, please. And so here, what it's doing is it wants to call an MCP tool from the Shopify MCP server. Here, it's asking me to approve or decline. That's an option that you can use with the MCP tool. So you can either ask the user for confirmation, or you can also bypass that. So you don't have to show the approval. You can also always approve. Here, I'm going to approve. And let's see. So it's listing directly the Cowboy box from the Cowboy Shopify website and showing me the results. And all of that, again, I didn't have to do anything. As you've seen, I just clicked a few buttons. We'll see what that means in code. But just by adding this MCP tool, I get access to all of that information that is on the Shopify website. Great. Okay. So that looks great. I think I'm going to take one of these later on. But let's try something else now. Let's try using the code interpreter tool. So the code interpreter tool, as I mentioned, it can execute code to solve problems, and it can generate like files, like charts as well, to answer your questions. So I'm going to combine it with the web search tool. What's great is that you can actually combine these tools together so they can work in tandem. And I'm going to say that first I'm going to see if what's the weather in SF again, to see if the web search tool works correctly. So here we're searching the web and we get some data. Oh, apparently we're experiencing one of its chilliest summer. Great. Now that I'm here, it's actually, yeah, I was pretty surprised by the weather in San Francisco. I thought it was going to be a little bit better. Okay, so we can ask something to the code interpreter tool to compare actually this data, because it says that it's one of the chilliest summer in decades. So we can ask it, okay, can you actually find the weather data on the same day for the past 10 years and generate a comparison chart? So here we're again searching the web for the historical data. And then, okay, sometimes one thing to note that happens from time to time, and it's a good thing to be aware of it. The web search tool can actually like spiral a little bit when it doesn't find what it wants. So I would include something in your prompts, like in your system prompt, to tell it like just do search it once and that's it, because otherwise it will like try to search for more. So when you combine the web search tool, especially with like other tools, that's something that can happen once in a while. So it's good that it happened here, because now if you get that issue on your side, you will know why. So I'm going to ask again, what's the weather in San Francisco, and then re-ask the question, and normally it should work. Doesn't happen all the time. I'm just going to say, add something like, yeah, just search for it once and then stop. Okay. So it's searching the web. Hopefully it doesn't spiral this time. And then the code interpreter tool should be able to analyze this data. So this is the code interpreter tool. It's running Python code, and then it generated a chart for us. And again, we didn't have to do anything here. I just added the code interpreter tool, and the code interpreter tool was able to say, okay, to find the answer to this question, that's the code I need to execute. It's Python code, so it's robust. It's not like LLM based, because, you know, LLMs, they're not deterministic. So when they look at data, sometimes they can get things wrong. Whereas here, you actually execute code. So you know that the answer that you get is the right one. And so code interpreters can generate files for you. You can generate charts, but you can also give it files. So for example, here, if I click the code interpreter tool to configure it, I can also configure this tool by giving it access to a file. So this file, we're going to use it in the next demo. I'm just uploading it, and now Code Interpreter will be aware of it. The next thing we're going to show in the demo, so I'm going to add it here as well, is the Stripe MCP server tool. So I'm going to add it from here. And all I need to do is add my Stripe API key. So this is a test key. And sorry. And it's connecting to the tool. So it's also offering a lot of different tools that I can have access to. I don't need all of this. All I need is the retrieve balance tool and list payment intents, and that's it. So I'm adding this tool. If I try it here, I can say, what's my Stripe balance? And let's wait a second. Again, it's connecting to the Stripe MCP server. Oh yeah, you can, I'm gonna actually redo that, and I'm going to configure the tool to not ask for approval, never require approval. That way I can try again. And it's retrieving the data from my Stripe account. Okay, great. So now that we've tested this tool, we can actually use them in our own application. So we're gonna imagine that we are a store, you know, an in-person and online store that is selling wellness products. So things like yoga classes and Zen kits and everything. And so as the store owner, the issue is that I have these different sources of data. So I have like data in my Stripe account. I have data in my for my offline store. Like that's in an Excel file. Like it's not easy to understand at a glance what my sales data look like. So I need to look up different tools. I also don't have an easy way to query my data. I don't have out of the box analytics. I'd love to be able to just ask questions to my data and see the results. So we're going to build a data exploration dashboard using the tools that we just discussed. So the MCP tool for the Stripe data, the web search tool, and the code interpreter tool. And so with that, we're going to be able to visualize and talk to our data in a much easier way. So just to give you an idea, this is what my sales data looks like. So it's just one extract for January to July, and it just contains things like the customer names and the items that I sold offline. And then everything I sold online would be in my Stripe account. So let's start simple just to get a sense of how you would actually implement the tools in your application. And so let's start with a simple Python script. So I already have like a boilerplate code to just do like a command line interface. So what happens right now is that if I run it, it will just like provide an interface for me to input something, and then it just says L world. So that's where we are right now. And now we want to integrate with the responses API. So what we're going to do is that we're going to replace that code here, and we're going to call the responses API with the Python SDK. So actually, Cursor already know what I want to do, so that makes my life too easy. Okay, I'm going to actually type it just for the sake of it, but yeah, so you can create a new response with client.responses.create. You can just specify the model that you want, and then you can also provide an input, and that's all you need. And then we want to print that. So we want to print the whole response to see what's going on, and we also want to print the output text. Okay, so let's try that again. I'm going to run the script again, and then when I say hi, this time we actually hit the responses API. So we get this response: hello, how can I assist you today? But that's all it can do now, because we didn't add any tool. Now we can gradually start adding our tools. So for example, again, Cursor is giving you a hint. We're going to try adding the web search tool. And so when I told you it was as easy as like clicking a button, I wasn't lying. This is literally all you need to add web search capabilities to your app. So it's that simple. Of course, you can customize it. As I mentioned, you can like give a user location. You can also set the how you want to search, like if you want to do very thorough search or more a lighter search. But for now, we're just going to add it like that. Okay, so let's run that again. And I can try again. What's the weather in Paris this time? And so here, the model will call the web search tool and then give us the answer. And as I was telling you, I didn't have to like handle the web search tool. It automatically was executed and the result was automatically added to the conversation context. So if we look at the response, what it looks like, we see that here, the model decided to do a web search call with this query, current weather in Paris. And then this is what it actually got from the internet. And automatically, it then added this answer that we see here. So with the data that it got, it was able to generate an answer, and all of that in one turn. Okay, so now we can add all of our tools that we tested in the playground. And the beauty of the playground is that you can actually take this, or actually, I'm also going to add, we'll add it in our other app, but when you use the Stripe MCP tool, you might want to add this to your system prompt, because the model doesn't necessarily know that you're looking at sense, and so your data might be like a little overblown if you don't add that in your system prompt. But we'll add it in our next app. Okay, so I want to integrate those same tools that I tested here in my app. So all I have to do is actually click here in code, and I can see the code needed to do that API call. So I could just copy paste all of that. I already have most of it, so I'm just going to copy the tools array here. So I'm going to copy that. Here we go. And then in my tools list here, I'm going to paste this. I'm just going to replace this by the environment variable that I have defined. And that's it. So this tools list, I'm going to import it in the other file here. So I'm going to replace that by tools list, and I just need to import it. Perfect. So if I run the script again now, we now have access to all of these tools. So if I say, for example, what are my last 5 payment intents? Oh, God, yeah, I might have, what did I do? Sorry. Error copy pasting probably. Let's try that again. Okay, so let's say, what's my strike balance? It's easier. Okay, so it's searching first, it's listing the tools that are available, and now giving me back the answer that I want. So again, it's called the MCP tool. If we look at the response here, it called the retrieve balance function from that MCP server, and then it used that. So this was the output of the retrieve balance function, and it used that to generate the final answer. Great. So now that we've seen like how to actually implement that in Python in a very easy way, we're going to integrate it into a real app. So for the sake of time, I already prepared this front end because we only have we don't have all day. So I want to just show you what it looks like, and then we're going to explain the code a little bit and add the tools gradually. So this is the demo app. Just to show you what it does right now, it's just it just takes an input and calls the model, but it can't do anything else. So if I say what's my strike balance, it's going to tell me what are you talking about. Okay, great. So if I show you what the code looks like, the most important parts are in this root.ts file here. And so all of this boilerplate code, you can, first we're going to share the code, the build our repo, but you also have all of that boilerplate code in the responses sample app, which is an open source app that we have that you can use to build with responses. And so here is what we're sending to the API. We're just sending the input messages. We're streaming we're sending the tools, which for now are empty. This is our tools array, so we don't have anything there yet. And then streaming the result to the front end. And we're going to talk about what's happening in the front end in a second. And also we have this system prompt here. So we just say what I was telling you about earlier when looking at Stripe values, keep in mind that you need to divide them, blah, blah, blah. Actually, this is USD. And just use web search. That's like a good tip for when you're building with multiple tools. You should specify to the model when they should use each tool. Like, for example, when we talk about online sales, look at Stripe data. When we talk about in-person sales, look at the sales data export, like use web search only when we ask you about external data. That's helpful for the model to know, because otherwise it might try different things and it might not be the right tool. Okay, so now let's add the tools array that we had just before in our Python script to that tools list in the dashboard. So I'm just going to replace that. And I also need to update this so that it's compatible with JavaScript. And now I can refresh and I can just say, what's my Stripe balance again? Not very original. And this time it should have access to this information because we just added the tools. So it's calling the retrieve balance and we can see the right answer. Perfect. But now we'd like to see the result in that dashboard that we have here. So we'd like to visualize it. And so for that, we're actually going to define our own custom function. And that's one example of a time where you still might need function calling and not rely on the hosted tools. But as we've seen for most tasks, you can actually now just use the hosted tools instead of having to define your own functions. For this one, since it's actually connecting to our own interface, we want to add a function that the model can use to populate the data in the dashboard. So we're going to create a function that's called generate component, and we don't have much time, so I'm just going to copy paste it from here and tell you what it does. So let me just grab it. Otherwise, it might take 5 minutes for me to write everything. And so this function, generate component, what it does is it's using structured outputs. By the way, if you don't know about structured outputs, check out the build hour for that, to define the schema of the components that we might want to use. So we're telling the model, you can use this function to generate a UI component, either a card, a chart, or a table. And depending on the type of component, that's the any of here, you can provide these parameters. So for the card component, we want a title, a value, and a description. And for the chart component, we want these things, the values that we should show in the chart. And for the table, we want to have the row data. So now that we added that, we're also going to update our prompt here to say that as soon as you have something that can be displayed, let me also copy paste that. As soon as you have something that can be displayed, you should use the generate component tool. And so the app is already set up to handle any tools that we want, but we have this handle tool function here, where if it's a function called generate component that the model wants to call, we're just using the result from that function to set the items that should be in the card in our dashboard, or set the chart data, or set the table data. Again, this code is provided, so if you want to see like how it works under the hood, you can check it out. But the main idea is that the data that we show in our dashboard here is just hooked up to a store. And so when the model uses the generate component tool, it will give us the parameters, the data that we need to update the store. Okay, so now that we've added that, let's try it again. So let's say, what's my stripe balance again? And this time, not only will the model call the retrieve balance MCP server, it will also call the generate component function so that we can update our card here. And now we can try other questions. So for example, I'm going to ask, can you search for my competitors doing yoga classes in SF and show it to me? And so this time it's using the web search tool that we gave the model. We just had to add that as, again, in the tools array, and it can search for the yoga studios, and again, calling the generate component, this time with the table, to show us the results in here. Okay, so now let's actually use code interpreter. And so as if you can remember, we added a file in the code interpreter environment when we configured it on the playground, that file. So now the model can know, okay, I have access to that file. I can run code on it to actually get the data that I need. And so here it's again generated component, and this time it's the chart component, the chart data that was updated with our data that was computed by the code interpreter tool. But the best part about using this in the responses API is that it's actually multi-turn, and the model knows how to use multiple tools in a row and combine these tools together. So for example, if I ask, can you list my Stripe payments from the last week, show me cards with the following number of customers, number of failed payments, and amount of failed payments, it's actually listing the data. Okay, and here it can actually figure it out on its own, but it might also have used a code interpreter tool to compute data if needed, and it's generating all the information that we want. And now we can visualize all of this neatly in a nice dashboard. And so all of that, as you've seen, I only had the dashboard, the front end, but all of the capabilities that allow the model to fetch the data, whether it is on the internet, whether it is in our Stripe account or in our own file, our CSV file, I just had to add this with a few lines of code, with just copy pasting the tools from the playground, and that's what I can get as a result in just a few minutes. Okay, so if I come back to the slides for a little bit to wrap it up. So why would you want to use built-in tools? So first of all, as you've seen, you can add them with minimal code. So it's really simple to just like turn this on. It's as easy as pasting in some code that you can find in the playground or just in our documentation, and that's all you need to do. You don't have any complexity overhead, so you don't have to write anything on your side. You don't have to worry about what's happening under the hood. We take care of that for you. So we take care of the complexity of, finding information on the web, optimizing a RAG pipeline, finding what is the right code to execute to solve a problem, and you don't have to worry about it. And as I mentioned, the best thing about the responses API and using this over multiple turns is that you can let us manage the conversation state. You can let us manage the history, and the model can decide to combine tools together and to solve complex problems by using all of the tools at its disposal to multiple times in a row if needed. And so if you want to build powerful agentic experiences, if you want to build an agent that can do a lot of things, especially with the MCP server that can give you access to anything on the internet that has an MCP server exposed, and all of that with minimal effort, then you can just use built-in tools and build something really powerful in a few minutes or hours, depending on what you build. But it's a way to go much faster when you're building. Okay, so I think now we are done with the demos, and
Yeah,
we're gonna
we'll welcome Hebbia's technical lead on stage. So Will, would love for you to join us now. Awesome. Hey, Will, how's it going?
Good. Thank you for having me.
Of course. So for everyone tuning in, we'd love if you could give a quick intro, what you do, and also what Hebbia does.
Sure. Um, yeah, so my name is Will. I've been at Hebbia for about a year now, and I'm a software engineer, tech lead on our agents team. So I'm working on all things agents, from chat and deep research towards our Matrix copilots. For those who don't know, Hebbia is a Series B startup based in New York, selling to financial and legal services. Really, at its core, Hebbia is a search company, and we like to say we're solving information retrieval. We have a few different products, a couple of which I'll demo for you all today. But every product does the same thing, sort of with a different flavor. And that is finding the right information and presenting that information to the user with the appropriate context. And I guess you can see in a video right here that's playing on the slide is a little sizzle video of our Matrix product, which I'll also demo for you live. And ultimately, that product is meant to do large-scale data analysis for unstructured data, so users can see insights very quickly. Before Hebbia, I was working on a startup, went through Y Combinator, did the whole founder journey for a few years, which was a fun and wild ride, and happy to be building AI agents at this point.
Awesome.
So, yeah. At this point, I guess I can talk a little about how we use some of these built-in tools. Does that sound good?
Yeah, let's just go on to this next slide. And then Will, let us know when you want to take over and start your demo.
Sure. So I guess thank you all for giving this presentation on built-in tools. A lot of what we do wouldn't be possible without them. I think that demo is great. I think it shows a lot of the really powerful things and that you can do with them. And I think with the right sort of like primitive tooling, as you add more complexity on top, especially with the rise of AI agents and multi-agent systems, you can build really powerful workflows. We do that for financial and legal services, and it's providing a lot of real value and saving people a lot of time. And once again, that wouldn't be possible without these built-in tools. So kudos to the whole OpenAI team for all the hard work here. The one I think I'll talk most about is web search in general. And we use it in many different parts of our product. I think two of which are particularly important. One is for just finding information. And two, I think one of the limitations that we have with LLMs is that they don't know everything, right? And that context is important. And the reason that people often have RAG pipelines or provide context to an LLM in general, because they don't know everything. And one of the other limitations that people don't often talk about is the knowledge cutoff. And so there's oftentimes in our product where users ask about things that the models actually haven't been trained on at all. And so we use web search as a way to get up-to-date information before actually going forth and doing long-running searches. And I'll give a demo of that as well. But to quickly show what you're looking at here, our chat and deep research products are often thought about through the lens of the explore-exploit trade-off, where we often want to explore the space fairly broadly first to get up-to-date on all the information, and then we exploit the different areas that we think are useful and relevant to the user's question. And to illustrate why web search is important here, one of the questions that was a gotcha for us was, can you explain how Trump's tariffs are affecting, my portfolio? The LLM only knew about Trump's first presidency and the tariffs that came with that, and wasn't aware of the new insights that you needed to glean. But if you can do a web search and get up-to-date information on those, you can then actually make more informed searches with web or other private knowledge bases to answer that question appropriately. And that is a little bit of the explore-exploit trade-off. Get up-to-date information, understand the space, and then go deep. So that's how we use web search. MCPs as well. We have our own multi-agent framework that we've built in-house. And we try to write blog posts for everything we do. It's exciting. If you want, you can read about it and how we use MCP and web search as well. All of it's public. And I think MCPs are great. It's a really step in the right direction of bringing offline data online, especially to LLMs. I think Hebbia tends to be pretty opinionated in the way we like to index data. And so we actually don't use a ton of MCP servers at this point, but we're always looking for ways to use them, because when you have the right MCP servers, it can save you a lot of time. So they're great. Okay, at this point, I can turn it over to a demo. If that works?
Yeah, we'd love to see this live. So feel free to share your screen and take over.
Perfect. So I'll walk you all through two of our products and explain how we use web search in both of them. So this first product is what you all saw on that animated video on the slide. It's called Matrix. And visually, it's a mix of ChatGPT meets Excel. So on the left side, we have what we call our Matrix agent, which is almost our co-pilot that can drive the Matrix and get insights across all of it. And then we have our actual Matrix product, which is a grid-like product that fundamentally structures information from unstructured sources. And so here we have a company first matrix where every row is all the information about a company. And if you want to add a column, you can, but I'll just show you what it looks like roughly. So every column is sort of a request for information about a specific company. Here, there's a context button. We also have document matrices where you can contextualize with the document or with web. But here you can contextualize with web. So you sort of like, you have your prompt that you send off to web. It's contextualized with other columns within the matrix. So this would be company name. And we go off, we search the web for the appropriate information, then we translate it into the format that's necessary for the matrix. So there's actually an example from the demo where it didn't know, the right format for a currency, right? And so one of the things that our matrix does very well is data formatting. We call this typed columns. And so you can actually specify the exact currency and the formatting you'd like for any single column. And there's also a translation layer, therefore, between the raw web output and what we actually show to our user. But ultimately here, web is used to just get up-to-date factual information regarding specific entities. And you can do this really at scale as well, which I think is the most interesting part, especially for our customers. Imagine you had a matrix with 10,000 rows, 10,000 companies you wanted to get information on. All you have to do is add a column, and we will do 10,000 web searches in parallel across all of these different companies, getting those insights for you and allowing you to sort of like make informed decisions downstream of them. So once again, thank you for building web. It allows our product to be even more powerful. And I'm going to switch over to a different tab at this point. And I assume you all can see this now. This is our chat and deep research product, which, I'm sure you all have seen products like this before. This looks and feels, like chat and deep research. The biggest nuances for us are the data sources that we have available. So we have web, which you'll see here, and I'll give a demo of that. SEC filings, and then private data like PitchBook, or private company data like PitchBook, structured financial data, which is in the form of, Snowflake tables, as well as other structured information, and then private sources as well. So what I want to highlight here with deep research, once again, is that explore exploit trade-off. So I'm just going to quickly ask, can you tell me about how the latest US tariffs are affecting EV companies? So the sources I've enabled here are web and SEC filings. So if I kick this off, we'll see what it does. The first thing it does is assess the sources, and then it's actually going to ask me some questions, which I'll answer. I'm just going to say yes to all, speed things up. Once again, we'll assess some sources, and hopefully my answer was enough to do it. Okay, and so to a user, what they're seeing in this multi-agent system underneath the hood are the actual executions that every multi-agent subsystem is doing. And so our web search agents are in this explore phase, where it's looking at very broad concepts. Once again, just to sort of beat that LLM training cutoff date, so we can then make more informed decisions. And here now we're generating a research plan based off of this broad search we've done. The research plan is then informed by what we found on the web. The research plan will include things like what to look for in future web searches, as well as what to look for in SEC filings, including both like companies and information. And then finally, that plan is then executed over pretty long time horizons, upwards of an hour. So I'll spare you the details here, but for every search we do, you can also see the status. So you see web searches, you see our public filings, index being searched for the exact documents, company, filing type, etc. And that's all on web. Maybe I'll quickly take a minute to talk about MCP as well, and I think why we don't leverage it as much as we should, but I think given the opportunity, we will continue to leverage it in the future. We're pretty opinionated in how we search for information, and I think what we found is some common off-the-shelf knowledge base MCPs don't quite meet the bar that we need to serve our enterprise customers. And so we built our own data indexing, and then we effectively wrap an MCP server around our own data index and use that. And so while we don't use like off-the-shelf MCPs very often these days, we do use sort of our own flavor of it internally with our multi-agent framework. Great, so I think that's everything I have to share.
Great.
So I can turn it back over to you all.
Yeah, thanks, Will. That was awesome. We love seeing web search in the wild being used for real life applications. So thank you so much for joining us.
Yeah, of course.
Awesome. We'll see you next time. Okay, cool. So we really only have 3 minutes for Q&A. So we're going to do a super fast speed round. Any questions that we don't get to, we'll send via email as a follow-up. So let's get started on the first one.
Okay. And I know we've already answered some questions in chat, so perfect. But again, if you have some follow-ups, we'll be happy to help. Okay, so I ran into a situation where I have too many tools, bloated the context window, confused the LLM. What are the best practices for managing that type of situation? So that's actually a great question. So indeed, when the model has many tools that it has access to, whether it's custom tools or built-in tools, sometimes it can confuse which tools it should use. And so I would always start with prompting the model very thoroughly to tell it, okay, you should use this tool when this situation presents itself and this tool when this other situation is here. And sometimes that might not be enough, in which case you might want to have like several agents that work together and you can orchestrate them to like focus on, each one of them can be focused on a specific subset of tasks. So each one of them can have their smaller set of tools, and then you can have like a sort of triage agent that can hand over to the right agent for the task. And so you can do that easily with the Agents SDK, for example, which is an easy way to build these sort of like networks of agents and handle that orchestration very simply. So I think we did have a build our own Agents SDK, but if you're not familiar with it, we have some content around it. We have it in our docs. We have sample apps for it. So I encourage you to use this if you're in the situation where you have like too many tools and the model can confuse some of them. Okay, so next one, I've heard that the file search tool can be useful to embed an LLM target description and a URL to that actual document rather than chunking the document. Do we have any control over this chunking strategy? So not as of now, but you do have some control for the file search. For example, you can do metadata filtering. You can also, if you want, you can indeed like just embed the description and then let the model find the most relevant documents and then complete that with your own retrieval if you want. You can also use the retrieval as a standalone API. So you can combine that however you want. I would say if you have a very complex RAG pipeline and you want like fine-grained control, maybe you want to build like your own RAG pipeline at that point. But if you don't have like very specific needs, or if you want to rely on our expertise because we're already doing that optimization process and already optimizing the pre-processing of the files, you can use the file search tool and like kind of offload that to us. So it's really up to you if you want to focus on that or not. I think we have, we're kind of over time.
We can take the rest of the questions offline. Will also got some questions in the chat, so we'll compile some answers and then send them over in a follow-up email.
Okay.
So let's just move on to
just to answer that one, the answer is just responses because it's a quick one.
And we also got a few questions on the shell setup that you're running for the animation.
Oh yeah.
So look out for that. We'll give you the full tutorial on that.
Yeah.
But here are some resources. Feel free to look at the follow-up email for these links or take a screenshot. And then I did want to plug that we have another build hour coming up August 20th as well as August 26th. So visit the homepage where you'll find all the details on the next one. Thanks again, everyone, for joining us, and we'll see you August 20th.
Thank you.